Hello everyone. So today now we will start algorithms. First we will see introduction to algorithms. So algorithm, it is a finite set of instruction that we are following to accomplish any particular task. So in our day-to-day life also we are preparing different algorithms. If we want to perform any task, always we are writing some steps how we have to complete that task. From the starting we are writing that how we should proceed for that is nothing but the algorithm. So whenever we want to write program that we want to execute uh, any computer language, for that also we have to write first algorithm, and then according to any language we are converting that by using the syntax of that language. So first we will see what are the characteristics of algorithm. What it should follow, some criteria that we will see first. That is, first is input. For any algorithm we should give 0 or more number of external input. It may happen that to perform any task externally we don't have to provide any input. Everything is given in that function itself. So in that case no input is given, but it may happen that sometimes we have to provide multiple inputs. Then second criteria, that is a output. Every algorithm, it will give some outcome, maybe one outcome or multiple outcomes it will produce, and to get that only we are executing that algorithm. Then third characteristic is definiteness. So each instruction which is written in the algorithm, it should be clear and it is unambiguous. From that only single meaning should come out, so that user can easily execute that instruction whatever is written. Next is finiteness. So when we are going to trace our algorithm, it should end at some point. Okay, so finite number of steps should be present in the algorithm. It should not go in an infinite loop. Then if it is going in the infinite loop, obviously we will not get any outcome from that algorithm. And last, that is the effectiveness. Every instruction whatever we are writing, that is going to be carried out. Okay, but it is not enough that your instruction which is written, that is definite, means that is clear or unambiguous, but that instruction, it should be feasible. Whatever we are executing, that is feasible instruction. It must be having a feasible execution of that instruction. So every algorithm, if it is following these 5 criteria, having input, it should have some output, it should be definite, then it should be finite, it should have finite number of instructions, and whatever instructions we are writing, that are effective, then we are saying it is a properly written algorithm. We will see one simple example, like if we want to find out average of n numbers. We know how we are doing average of n numbers. One by one we are taking that numbers, how many numbers are there, we are adding that numbers, and then we are dividing that addition by n whatever we have specified. So the skeleton of algorithm is always it starts from start and it will be having end. Then in between you have to specify your number of instruction. So first it will start, then we are saying I want n, how many numbers I want to perform average, for how many numbers I want to perform average. So that n is going to vary every time. So that I am asking user that enter whatever n number of users you want to input. So that n value will be taken, then whatever n I am specifying, that many number of elements I need to be inserted in my program. So now here I am asking one by one number to the user, adding that number to some variable, that is sum, and then this process I am repeating till I have not entered all the n number of elements. Once I am getting that all numbers are entered, it will come out from the loop, and then I am just performing division of that complete sum divided by n. So here whatever instructions I have given, written that are just simple English statements. Okay, so these English statements I have written, and from that obviously these are very easy to understand. English statements are very easy to understand, but it may happen that sometimes we are writing any instruction, it will be giving you, or maybe as the language changes, it will take different meaning of that. That's why what we are doing, we are making that whatever algorithm we are writing, we should represent in some fashion, so that irrespective of any language where you are executing your program, where you are trying to write that program, user will come to know that what I want to perform, what action I have to perform when this instruction is written. For that, for representing algorithms, we have two different methods. One, we are representing algorithm in the visual form, that is a flowchart we are drawing, and another is writing pseudocodes. So visual representation, that visually we are drawing the step by step how we are executing, graphically we are showing that. And second, pseudocode, it is nothing but simple written in the short English phrases, but now these phrases are making use of keywords which are not related to any computer language, but their meaning will be same. If I am saying that input means, it will come to know that I have to scan the value. So if I am writing program in C, I will use scanf to execute that instruction. If I am using C++ as a language, I will write cin instruction for that, or in different languages, in Java, in Python. Accordingly, I will write how to take the input from that. So now we will see how we will see one by one how the flowchart and your pseudocode will be written. So in the flowchart, as this is the graph visual representation, we have some symbols available that we are using. Start and end. So this is the ellipse we are using. Then for input and output, we have one rhombus. For processing, we are making use of rectangle. For conditional statement, you have diamond. So in that diamond, you are specifying your condition. If that condition is true, it is going to yes. If it is false, it is going to no. If you want to call internally any procedure or function in our code, then we are making use of function or procedure symbol. So there we are specifying the name of function and the parameters of function. Then this is connector. So this is on page connector. If on the same page you want to go to some other place, some other position, we are making use of connector for that. Off page connector, if on one paper you have completed your work and on the next page your flowchart is going, so in that case off page connector will be used. To show the loop, we are making use of loops. Okay, so these are the normally used symbols in the algorithm, in the flowchart to represent algorithm. So again, the algorithm which we have written, that addition of or finding average of n numbers, we will try to represent it using. So here you can see this is the start, which is start symbol. Input n, so this is just in, we want to input the number of elements which we want to perform average. Then I have to do some initialization, because I am going to add that number which is given into sum. So I am making sum should be equals to 0. This showing loop, that when your I is less than n, you go and enter the new number, add that number. So this is processing we are doing here. So sum is equal to sum plus number. This is the processing symbol. There we are doing addition, and then after performing addition, it is as I is less than n. I think I have forgot here. There should be one connection from sum to loop. here your I is less than n, so it will go back to the loop. It will take new number. When it is greater than this, I is greater than n, it will come back to the average. So now here in the average it is going to calculate. So here one correction is there, that from sum, this particular box, we should have one link which is moving to the loop. So here it will take the number and it will go back to the loop. There it will check the condition that I is less than n, and as it is less than n, it will come to this part. If it is greater than n, then it will come to average. It will calculate average, display that average, and then end the program. So next part is pseudocode, writing pseudocode for the algorithm. So pseudocode, it is informal way of programming description that does not require any strict programming language syntax or underlying technology consideration. Means here whatever we are saying, irrespective of any language, pseudocode will be written. Once I am writing algorithm in the form of pseudocode, then by referring that pseudocode, I can write code for that in any language. Maybe it is C, C++, Python or Java. So whatever keywords I have written, that doesn't have to do anything with the language what I have written. Okay, so keywords are defined, but that keywords are irrespective of any language. So pseudocode is understood by programmer of all types. So whatever programmer which are doing programming of any language, they will understood in the similar way what they are doing. It enables programmer to concentrate only on algorithm part of the code development. So once they are getting the clear picture that what that instruction trying to gives input, and it cannot be compiled into executable program. So like whatever instruction is given in the pseudocode, as it is, if you are writing in the program in your code, then it is not going to execute, because for every language you have your syntax. Here one example is written, like if I is less than 10, then in I++, do the increment you are doing. So here in the pseudocode you are writing that if I is less than 10, increment I by 1. Okay, so from this I will come to know that I have to increment by 1 if it is less than 10. So in Java it will be written like this, that if I is less than 10, then in the braces you are writing I++. But in Python you will write if I is less than 10 and then colon you have to give. So this is the syntax of this, and then it will be I is equals to I plus 1. In your Python code you have to concentrate on the indentation. If it is written inside by giving tab, then only it will be considered that this statement is under this if statement. So from this we will come to know that I am getting that this particular task I have to do. But when I am writing a code with the different language, accordingly I will use the syntax of that language and I will execute that instruction. Okay. So now we will see again our previous example using pseudocode notation. Before that, there are some pseudocode notations available which are used in almost all the algorithms for representing algorithm by using pseudocode. So start and end to start the algorithm and end the algorithm. Input, read or get. These are the keywords or the notations used to take the input from the user. To display or output the data, then print or display, this will be used. Calculate, determine, it is when we are performing any operation, that time calculate or determine, these keywords are used. Set, initialize, to initialize value, to give some value to the variable, we are making use of set or initialize, or it may be written as a colon equal to, like that also. Increment, decrement. So after this we will write by how much you want to increment and how much you want to decrement. So increment, decrement, by default it will be 1. increment by 1, decrement by 1, or increment by and some value. X gives y, so this is assigning value of y to the x. So again, notations for conditional statement: if condition, then statements. So then whatever statements you want to write, end if else part is not there. If else part is there, then if condition, then whatever statements you have, else whatever statements you have, then end if. Again, in the else also you have another condition available, then else if we can use. So if condition, then statement, else if condition, then statements, and end if. So whichever if you have, for that every if you have to write end if, then only it will be correctly understood. If case structures multiple in by using a case switch case, if we are writing a code, then case, whatever is the expression you want to specify, what are multiple values you are checking, their values, and default value if it is there, and then the end case. For the loops, loop, condition, and then whatever multiple statements are there, and end loop is required. Loop statements, if you are using do while loop, where initially only condition you are not specifying, I want to specify condition at the end of the loop. So loop statements until this is the condition. So this way we can write step one by one. We can make use of these notation for writing pseudocodes. This is the example. So start input n. So now in algorithm we have written so big statements that enter the number of values to be given for the program. So here enter n, it will come to know that n is already defined for given numbers. So it is input n. Initialize I to 0, sum to 0. Loop. In this loop what I want to do? Read number into no. So in no variable I am reading first number, and in sum I am just adding the sum to the number. This I am repeating until I is less than n. Okay. Now here I am not giving any semicolon or anything. It is not required because in some language it is there that semicolon is considered as a terminator symbol, but it is not required because this is not with respect to any language. So even though it is not given, it is not required. Then average is equal to sum or n divided by n. Here you may write compute or sum divided by n. That is also possible. Average equal to compute sum by n, and then print average and the end. Okay, so these are very simple example we have seen. Whenever we are going to see different data structures and different type of operations on that data structure, for all that operations we will see one by one pseudocodes. Okay, so here one example I have given, that is very simple example. We want to find out largest element given in the 3 element. We know that suppose I have 3 students and I want to find out the student who has got the maximum marks. Okay, so what I will do, that I will take any one of the marks, I will compare with other one. If it is greater, then I will say the first one only I will compare with the next, that is the third one, that whether it is greater than third one or less than. If it is greater, I will declare that that first one is having the maximum marks. But now when first and second I am trying to compare, in that case suppose first marks are less, then I will take marks of second student and third student I will compare. Who is having greater mark, that person is having the maximum marks. So logic we know, now we have to write the steps for that. So we will see algorithm also, then flowchart for the same example, and pseudocode for the same example. So first algorithm, start. Enter the value of 3 variables. in A, B, C. So 3, I want to find out largest element for the 3 elements. So 3 values I am entering. Check if A is greater than B. Value of B. Value of A is greater than value of B. If A is having greater, so if this condition is true, so what we are writing? I have to go here. So if condition and the step 3 is true, then I will go. If true, then check A with the C, whether A is greater than C. So here I have written purely English statement, greater than, less than, like this. Okay, so A is having greater value than C. We will say in the, so in this, if it is true, then I will say A is having largest. But if it is not true, then I will say C is, if it is false, then C will be having the largest value. Then A is not having the greater than C. Okay. If A is not having value greater than C, means what? Now I need to check with the B. A is smaller. So now I will check C and B. Whether B is having greater than C, then B is largest. Otherwise C will be largest. Okay. So if A is having value greater than, flowchart for this, A is having value greater than B. So A I am checking with C. If B is having value greater than C, then B is having largest value. So here we can come to know that how we are solving a problem, same thing we have to write the steps also. So here we could see, first start inputting 3 values. In the conditional statement I am checking A and B. If A is greater, then A is checked with C. If B is greater, B is checked with C. Now pseudocode, start, again here start, read ABC. If value of A is greater than B, then A will be checked with C. Display is larger, else display C is larger. So these are the 6 assignments I have said. We have to write algorithm, pseudocode and flowchart for all these problems.